2. Lydia.
She was in my house.
Lydia Pittsburgh?
Yeah.
Yeah, no, she dropped.
You were just doing it.
Yes, that's fine. Okay. So we're gonna go back in our memory banks to 8th grade. I'm guessing for all of you. And in 8th grade, we did system of equations. All right, and we had 2 equations, and one of the method for solving was by graphing. And let's say we had the equation y equals 2x plus 3. Actually, let's make it a negative 2x plus 3. So down to over 1. And so that line looks something like that. And then we had that second line, and let's say it's y is equal to 1/2 x minus 2. And so up 1 over 2, 1 over 2. And my line would look something like this. And this point right there, whatever that point is there, that was my answer, because that was the point of intersection. Remember that? Okay. Then we learned how to solve using substitution. Is this ringing bells? Little? Okay, so you write your equations, you pick one that looks less complicated, and solve for one variable, then substitute it. So, let's look at the first one. Which one do we want to use to, which one do we want to solve for a single variable? Yeah, because if I subtract 2x, I'm going to have y is equal to negative 2x plus 4. And then since y is the same thing as this, I can substitute in for y there, which then gives me 3x plus 2 times negative 2x plus 4 is equal to 1. And the beautiful part about that is now I only have one x, and so I can just solve for x, and there's half of my answer. So if I distribute, I'm going to get 3x minus 4x plus 8 is equal to 1. And then these combine to give me a negative x. And if I subtract 8 from both sides, and then since I can't have that negative x, I'm going to flip my signs. And so x is equal to 7. So I have half my solution. Remember what we do next? Plug 7 in for x. Does it matter which equation I'm plugging it in for? No. Which one's the easier one to plug it into? Did I lose you? Okay, where at? When what? Here? Okay, so since y was equal to this amount, okay, so then I distribute that 2. So 2 times negative 2x is going to give me negative 4x. And then 2 times 4 gives me the 8. Okay? And then 3x minus 4x gives me negative x. And then I subtracted 8 to give me the negative 7. Good now? Yeah? Okay. All right. So which equation, the first one or the second one, did you want to throw it into? First one. I would do the first because y is by itself. And then I don't have to do any more steps, so I have 2 times 7 plus y equals 4. So 14 plus y equals 4. And so then y is just equal to negative 10. And so my answer is 7, negative 10. What?
So you can just put back in that one.
Yeah,
Oh, okay. That was just,
you can.
Yeah. Right.
Yep, you can. All right. Let's look at the next one. Do you want to solve for G or for H? Okay, first question, does it matter? No, it really is not going to matter. I'm going to go ahead and just solve for G just because it's on the top. And then I will substitute it in, so 1/3 of negative 3h plus 8 plus h equals 9. Okay. Now, when I distribute, I'm going to get a negative h plus 8/3 plus h equals 9. Good so far?
Yeah.
All right. Look, my 2 h's cancel. And so I'm left with 8/3 is equal to 9. I don't like that. What does it mean? Is that true? No. So it is a false statement. Okay? Now, let's think about what that means. Our goal and our solution is an intersection point, right? If I wipe out my variables and get some false statement, what does that mean about my solution? They don't intersect, right? That means there's no intersection. And if 2 lines don't intersect, what kind of lines are they? Huh?
What would you say if they don't intersect?
If they don't intersect, what kind of lines are they?
Parallel.
Parallel. And basically what our answer is that there is no solution. Seems like it's dark today. Is it dark today? The light up here?
Actually, I don't know. It's been a while.
Yeah, I haven't seen you in months. All right, ready? One more? Okie dokie. So, which one do you want to solve for? I want to do the second one because my A is by itself. Yes, you do. So that's okay. All right, so if I have negative A is equal to negative 2B minus 3, but I don't want a negative A, so I'm going to flip all my signs because math lets us do cool stuff like that. And now I can substitute into the first equation. So 2 times 2b plus 3 minus 4b is equal to 6. Good so far? So when I distribute, I'm going to get 4b plus 6 minus 4b is equal to 6. What happens this time? My 4b's cancel, and so I get 6 is equal to 6. Okay? Now, this time, instead of having the false statement here, we have a true statement. So basically, it's like saying, up here, we were saying there is no number that equals the solution. This one's saying there's one specific number that equals the solution. If we have a true statement, what do you think that's going to mean? Remember? Every number is going to be a solution. Okay? This means it's basically the same lines. And so it is all solutions. Think of it as the two lines are laying on top of each other. And so every point is an intersection point. Is this ringing bells? It's one of those where it's like you haven't done it for a while, you forget all about it, and then it slowly starts coming back to you. It slowly starts coming back. Okay, that's substitution. Anybody remember what the other method of solving them is? Elimination. This is my favorite one. Much easier. Okay, so the goal when you're doing elimination is you want to get so that you have the same coefficient and different signs. That's your goal. Okay? And then you're going to usually add the equations. Add or subtract depending on your signs. All right? So, the very first one. Look at that. 4x and the negative 4x. When I cancel, or when I add my two equations together, I cancel out my 4x's, which then is going to leave me with 5y is equal to 25. And so y is equal to 5. So much easier. How am I going to go about finding x? Plug it in. Plug and chug. All right, Jennings, you want the first equation or the second one? All right. So 4x plus 2 times 5 equals 9. So I have 4x plus 10 is equal to 9. If I subtract 10, 4x equals negative 1. And so x is equal to negative 1/4. Looks like an 8. There's a 9. All right. The next one, number 2. What should we do? I don't have anything that looks the same. I don't have any coefficients. Like my 4 and negative 4 were the same last time. What do I want to do this time? Say that? I can't subtract yet because nothing's going to cancel out. If I subtract it, I'd get x minus 4y. No, can't do that yet. Think about what my goal is. My goal is to eliminate one of the variables. How do I make something go away? Do the opposite, okay? So, all right, let's pick. Which one do you want to go away? 2 or X or Y? Doesn't matter. Which one you want? X or Y? Y, okay? So, I would have picked Y because one's negative and one's positive. I don't have to worry about the sign. But this one's a 3. So, if I multiply this one by 3 and distribute, I get 3x plus 3y is equal to negative 36. And now, when I have the two together, my y's cancel, and I get 5x is equal to negative 30. So when I divide by 5, x equals negative 6.
So you just made a negative to a positive when you're multiplying 3 by x plus y.
3 times x gave me 3x.
Yeah, but for that 3, did you make that from the negative 3y?
I kept, yes. Since this was a 3, I multiplied it by 3 so that they would cancel each other out. Yeah. Good? Am I done with that one?
No.
Which one do you want to throw it into? The one I created, bottom? Or the one we started with, bottom? Doesn't matter. You can choose whichever one you want. So I'm going to do the started one because it's x. It'll be easier. My y is single, but it doesn't matter. And so y is negative 6 as well. Okay, now on this last one, like my x and y, that was pretty easy. I could multiply one equation by a number so that stuff matched up. But when I look at number 3, I don't really have anything to like just multiply ones by, right? So what I'm going to do is I'm going to say, hey, I want to get rid of the x. All right? So I need to make both of these a common number to get rid of them, right? I was going to just do the x though, not the y. You can do the y. You can do the y. That's fine. You can do the y if you want. I don't like the multiples of 7. I have to think. So I'm going to go with the x. Sarah's going to do y. So since I need a multiple of my 2 and 3, that means I'm going to multiply the top one by 3 and multiply the bottom one by 2. So just take the coefficients of the two you want to get rid of. And I'm going to make sure, since they're both positive, I'm going to actually even go one step further and multiply by a negative 2, because then they'll just automatically cancel out. Good? All right, let's distribute. So 6x plus 21y is equal to 12. Negative 6x minus 10y is equal to 10. My x's cancel, and I'm left with 11y is equal to 22. And so y is equal to 2. Now, to find my x, now that I know what y is equal to, I could put it in the very first equation. I could put it in that second. Yeah. You could have multiplied by a regular 2, but then you would have ended up with a positive 6, and you would have had to remember to subtract everything then. And so when I do my multiplication, I multiply to make sure I end up being 1 positive and 1 negative, because then I can just add everything. I tend to lose sometimes when I'm subtracting the two negatives and all that good stuff. So if I can just combine and add together, then I try and keep it that way. Does that make sense? Okay. All right, so I could put my y equals 2 into the first one, the second one. I could even put in the third or the fourth one that was created. It doesn't matter. All right. Sarah, you want to should we do the first one and use your 7y?
Yeah.
Okay. All right, so I'm going to get 2x plus 7 times 2 equals 4. So 2x plus 14 equals 4. And so 2x is going to be negative 10. And so x is negative 5. Good? Feeling good about those so far?
Yeah.
Is that kind of coming back to you? Okay. Matrices basically is solving system of equations, but with like 3 or 4 or 5 variables kind of thing.